So, our next presenter is my dear friend and colleague, Tim Newfield. I've known Tim since I started teaching 16 years ago. He was in my very first honors seminar class at York University. And as I tell people, it was like there was a spotlight on him. The light was on, and it was obvious from the time he opened his mouth that he was going to be standing here as the newest appointee to the history department at Georgetown University, where he's moving in January from Princeton, where he is now. Tim is highly unusual and hopefully the model that all our new students in the audience will be following. He's cross-appointed between history and biology, which 20 years ago would have been unthinkable, but increasingly with topics like environmental history just makes good sense. So Tim, take it away.
Thank you for that introduction, Stephen, and for having me here today. I'm very happy that I can participate and that I have been able to participate in this project for a couple of years. Let's press to this. Okay, there we go. As a member of the interdisciplinary Herstmonceux project, I am helping to reconstruct patterns of climate, short and long term, locally for Herstmonceux and regionally for southeast England. By weather, I refer to a season or a year's worth of temperature and precipitation. By rapid climate change, I refer to quick and temporarily sustained changes in temperature and precipitation lasting less than 10 years. As I am concerned with the period spanning 1200 to 1450, my part in the project covers the transition from one climatic era to another, from the so-called medieval climate anomaly to the little ice age. Sorry, I have a speech impediment. Sometimes I go straight to the blackboard, but from the medieval climate anomaly to the Little Ice Age. I seek to synthesize the available paleoclimatological work that is proxies for pre-instrumental temperature and precipitation, and to flesh out these natural archives of past climate with written data of all sorts, from chronicles to correspondence to manorial accounts. My results will, at the end of the project, be meshed with the climate and weather indications unearthed, perhaps at Herstmonceux, and they should, I hope at least, shine light on one of our primary questions. Did the emparkment of Herstmonceux correspond to a deterioration of climate conditions? This reconstructing of 2.5 medieval centuries of climate is no easy task. To begin, there are yet no high-resolution or annual or decadal scale natural climate proxies for medieval or early modern Sussex, or the southeast in general. And the written sources are a little bit patchy. Some would say they're very spotty. I have decided, however, to begin with the manorial counts, the bread and butter of our previous speaker, Helop Slavin. Medieval English manorial counts are detailed agricultural and financial reports that were compiled annually on September 29th, the Feast of St. Michael. They record, among numerous things, the grain sown and the grain reaped, kind by kind, and allow for the calculation of yields. These remarkable documents survive in great quantity for many English counties between roughly 1275 to 1425. They have been employed by historians for over a century to reconstruct agrarian economies, human diet, livestock trade, trade in all sorts of goods, market activity, and the like. Recently, manorial accounts have been employed to comment on past climate. Around 2010, Bruce Campbell published the first of 4 studies that he has presented that use yield data, his national yield index, that is grain yields from across England, with Irish oak precipitation proxies to illuminate general patterns of climate in medieval England. More recently, Kathleen Preble employed grain harvest start dates notched into the manorial counts to establish an April to July mean temperature series for Norfolk that spans 1256 to 1431. The value of these sorts of documents, of manorial counts, for teasing out medieval English climate at a national, regional, and local level is clear. It's yet to be fully realized, however. The problem is that manorial counts have not survived for all manors and for all years. In fact, good continuous runs of accounts, as Phil can attest, that expand a century or even 50 years are rare. More often than not, these records are patchy. To validate or corroborate the signal of climate that manorial counts can provide, it is important to read at least partially the accounts alongside an independent proxy of climate and WEATHER, weather, a high resolution one. Again, no such proxies exist for the southeast. To make matters worse, the manorial counts that survive for Sussex are rather thin, and only a single count discovered maybe a month ago, I'm not sure, Phil, discovered by Phil, survives for the settlements lost beneath Herstmonceux Castle and Estate. Despite the slenderness of the written and physical material for a local and regional history of climate and WEATHER, weather, all is not lost, though it probably seems like it is. There are more than 10 manors in the general region of Herstmonceux endowed with manorial counts. Together, these comprise what I've been calling the Herstmonceux accounts database. This will be expanded in good time with Philip's help to include more sites, coastal sites, closely located to Herstmonceux. Of these, one series of accounts stands out. Battle Abbey, built on the supposed site of the Battle of Hastings, sits about 13 kilometers east of Herstmonceux. It operated a manor roughly 26 kilometers southwest of Herstmonceux called Alkeston. Alkeston has a spectacular run of accounts, the best in the HAD, or the Herstmonceux account database, as I've been calling it. Gross yields per seeds can be calculated for wheat at Elkinson for 119 growing seasons between 1336 and 1492. The gross yield per seed represents the number of grains reaped for the number of grains reaped per seed sown. This gross yield per seed ratio, of course, fluctuates sometimes wildly year to year. The average yield at Elkinson over the longue durée was 4.2, that is over 119 growing seasons. But as you can see on this graph, some years were quite good and some years were quite bad. In 1404, the yield was supposedly 7.9. Yet, 21 of Elkinson's harvests were more than 25% below the average of 4.2. For instance, the yield of 1444 was a whopping 41% below average, and the yield of 1471 a disastrously 46% below average. How representative good and bad years at Elkinson are of wider regional trends in the southeast is uncertain. This graph plots gross yield per seed ratios for 4 other of the HAD manors. I will not discuss this graph in detail here. I simply want to point out first that yields varied significantly between these manors, and this is on account of local environmental conditions, largely, such as soil type, soil fertility, slope, the elevation, and local precipitation patterns. I also want to point out that the accounts for few HAD manors overlap with those of Elkinson, or even come close to approaching 119 growing seasons. Additionally, very few of the HAD farms have accounts for the 14th century, and as you can see, the vast majority of the Elkinson material is 15th century. Sorry, I meant to say, obviously very few of the HAD farms have accounts for the 1400s, yet the vast majority of the Elkinson material is 15th century. Manorial counts are capable of providing a signal of phenomena that affected harvests on a regional scale in the southeast. This is, I believe, important for reconstructing Herstmonceux's medieval climate and WEATHER. This slide emphasizes the spectacularness of the run of accounts at Elkinson relative to the okay and downright poor showing of the other HAD manors. Petworth Manor, some distance away in Sussex, provides or possesses yield data for merely 4 growing seasons, albeit 4 important growing seasons that span the pivotal Black Death era. Just what environmental signal we can get from the yield data can be difficult to determine, or is difficult to determine. Many factors, of course, affect yield, such as the supply of drought power, the supply of fertilizer, and human labor, not to mention, as I've already said, slope and elevation, precipitation, soil fertility. Still, extreme weather and rapid climate change are perhaps the most influential factors to consider. I propose that when yield trends, positive or negative, agree across the HAD, this small HAD, and soon to be the expanded HAD, when they agree across the database that we are looking at a regional southeast England deviation from normal or baseline temperature and precipitation. When positive or negative trends across the HAD align with the national trends already identified by Campbell, I propose Herstmonceux was experiencing a deviation in climate patterns experienced across England and often the entire North Sea region, as is the case during the Great European Famine. Moreover, when HAD yield trends align with Campbell's national trends, we often know the cause of the atmospheric unsteadiness, as Campbell already in 2009 married his national yield index with natural archives of past climate and precipitation, notably high-resolution tree ring chronologies from Ireland. When there is agreement between the HAD manners, but not with Campbell's national index, we unfortunately do not know the cause yet, as again there is no high-resolution natural archive of temperature or precipitation in the southeast. There may be one soonish, however. 2 annually resolved precipitation indices for pre-modern England have been published since 2012. Both use living and historical oaks, or archaeological oaks, if you like, from low elevation regions. Because they're coming from a low elevation region, they can at best tell us about precipitation. We are never going to get a temperature signal from trees for this part of the world. These 2 tree ring series provide us with a proxy for March through July rainfall on a year-by-year basis, extending back to roughly 900 AD. The first concerns East Anglia, and as such, I won't be talking about it today. Right here for those in the back. The second, which was conducted by Rob Wilson, regards what the author refers to as South Central England. This study, or this map, this second study, as this map shows, included some historical or archaeological tree samples from Sussex, albeit a very small number of them. Indeed, Wilson's study sampled 1,892 trees. A mere 42 of those trees came from Sussex. More than 150 came from Hampshire, Oxfordshire, Wiltshire, and Greater London. The study cannot therefore be utilized, or nor has it been used, to study rainfall patterns particular to medieval Sussex. Fortunately, a similar tree ring series might be planned for southeast England. When it appears, after it's been conducted, maybe we're looking at 4 years, we will learn much more about the causes of regional yield fluctuations registered in the Herstmonceux account database. Okay, so I've considered how national and regional events can be teased out from manorial counts. Now, local events. When yield fluctuations are discordant within the Herstmonceux account database, the cause was clearly local. As I've understood, or sorry, as I've underscored, I hope I've understood. It is important when attempting to understand local deviations to consider local factors. Concerned as we are with Herstmonceux, it is essential to study closely the data from the other HAD manners that I already have of Agni and Appledore. Herstmonceux, as you've heard a few times today, sits next to the Pevensey levels, an extensive marshland in Sussex. Reclamation projects began in this area in the mid-1100s, and crops at medieval Herstmonceux were grown in some areas at a half meter above sea level. In 1361, for instance, we know from a contemporary account 350 acres of crops were grown or were cultivated in, quote, low-lying marshland at Herstmonceux. A similar situation was playing out at Agni in Appledore in the Romney Marsh, 50 kilometers to the east in Kent. In the Romney Marsh, the Dymchurch and EARTHEN, earthen walls, there we go. We're built, the suspense is what sells. Earthen walls were built in the 13th century. They helped to allow permanent, if vulnerable, settlement on the marsh. Despite reclamation projects, local inundations and storm tidal surges are a probable cause of many of the Agni and Appledore's 13th and 14th century crop failures. So too heavy precipitation, waterlogging, and internal river flooding. When events of this sort affected these Romney Marsh manors, arable at Herstmonceux was likely affected too, or at least I propose. It is hoped that archival and archaeological work, and here I'm passing off the work at Herstmonceux, will identify evidence of flooding events that corresponds to poor yield eras at Appledore and Agni. This map shows the Pevensey, This map shows the Pevensey and Romney lowlands circa 1100 before reclamation, before major attempts were made to reclaim land. It gives an idea of the vulnerability of Herstmonceux to flooding and years of heavy precipitation. By 1500, much of this land had been reclaimed, but it was not terribly well fortified still against the English Channel. So here we're looking at the Pevensey area and the Romney Marsh. Okay, changing gears. It is clear that Herstmonceux and the Had farms were not immune to the major crisis years that Campbell has observed at a national level. For instance, Herstmonceux undoubtedly suffered during the Great European Famine, which Phil has just spoken of, along with other areas of England and the continent. The Had testifies to this. Yields can be calculated for 8 Had manors for multiple years during the Great Famine. The number in brackets down at the bottom, if you can make it out, is the average yield at that particular farm over all of the years for which we have yield data. So the average yield at Appledore was 2.76, and it failed to come close to this average in the worst years of the Great European Famine. Yields on Had manors in one of the worst years of the famine, 1314, 1315, were on average 31% below 31% below normal on average, slightly better than Campbell's national mark of 39% below average. Agni and Appledore, however, were a staggering 55% below average. We know heavy rains and storms triggered crop failures and food shortages at this time. Multiple lines of independent data indicate this. That the Romney manors fared badly in comparison to both the Had manors and to Campbell's national index in these particular conditions suggests strongly that the wetness that triggered the famine in general disproportionately affected low-lying sites, and that, like the crops of Appledore and Agni, the crops at Herstmonceux very likely suffered more than elsewhere. A similar situation played out during the harvest crisis leading up to the Black Death's arrival in England in 1348, and during the third English visitation of the Black Death in 1369. I do not have time to get into these here, but clearly via manorial counts, particularly those included in the Herstmonceux account database and Campbell's National Index, we can begin to tease out and understand the local climate and weather experience of Herstmonceux and how it related to regional and national trends. Of course, it will be essential going forward to marry these written sources with the paleoclimate available and, if possible, to generate new paleoclimate data. Just one last bit here, one last bit. A very large international team of dendroclimatologists drew on all millennia tree ring series available for Europe in order to reconstruct what is called the Old World Drought Atlas. This atlas uses the aforementioned dendro studies for the UK. The signal the trees give was paired with modern European instrumental data spanning more than a century, and the precipitation of each year indicated in the trees was then illustrated. This is the drought atlas for 1315. Here we see the trees independently verify the information gleaned from written sources. 1314, 1315 was very wet. I should have blown this up more because we're really not concerned with the content at the moment, and we're just looking right here. So the darker the green, the more the wet. So in Anatolia, things were pretty dry. But in Northern Europe, and in particular for us, in this little corner, things look to be pretty wet. Many other years are markedly bad or markedly wet at Agni and Appledore as well. These, thanks to the atlas, can also be tied to heavy spring rainfall. This is the drought atlas for 1321, and again, if you can make it out, we have particularly dark green here in the far southeast. 1328 was another damp year, but this time it's really located or constricted to the southeast. Here the atlas suggests that the exceptional wetness was indeed very localized. 1283 was another exceptionally bad year at the Romney Manors, and the atlas shows heavy rain, especially in the extreme southeast. So here I'm able to use tree rings and manorial counts to provide two independent lines of evidence that clearly indicate bad yields in certain years are being caused or being triggered by exceptional wetness. Other years of known flooding or heavy rain in the southeast, like 1340 and 1366, also come up green in the atlas. This looks great and everything, but it's not as great as it seems. We can't rely on the atlas for everything. The trees again tell us only about March through July precipitation, and we must recall that summer, fall, and winter trends could be very different. And additionally, the Sussex tree ring data is very few. So if it's very hard to make out, but there's actually, this white line is what we have no data right for where we're interested. And the vast majority of this data is model data. It's not coming directly from trees. So here we are, see, data list, so it looks great, data list. Okay. Additionally, we're only getting the precipitation signal from spring, but knowing that can help explain some surprises that come up in the atlas. This is the precipitation map for 1287 and 1288. These were the years of great rainfall and extensive flooding on the Pevensey levels as reported in multiple sources. The atlas, however, shows these years were some of the driest of the 13th century in general. Indeed, the darker the brown, as you might expect, the drier. But again, dendral evidence for Pevensey is slight. Rainfall could have occurred after, could have occurred after spring. Okay. So there's clearly a need for a new dendroclimatological series for the region of Sussex. First, I need to expand the HAD database and to assess carefully the manorial data against the paleoclimate data that is already available in an effort to begin to establish a correlation between precipitation and yields, and whether the trends deteriorated over the region, in the HAD region, in the decades leading up to Herstmonceux emparkment. Doing so will allow us to understand the role climate change may have played in the transformation of Herstmonceux, if any, in the mid-15th century. So at this point, I'm really not interested in causation, I'm just interested in being able to establish correlation. But correlation, of course, as Phil has been reminding me daily, is not causation. Thank you.